Alrighty, AP style problem number 3. You'll notice if you can read it, the continuous function f is defined on the closed interval -5 to 5. The graph of f consists of a parabola and 2 line segments, as shown in the figure above. Let g be a function such that g prime of x is equal to f of x. I'm just going to circle that for right now. We're going to maybe need that in a little while. So, all right, for part A, it says to fill in the missing entries in the table below to describe the behavior of f prime and f double prime. Indicate positive, negative, or 0, and give reasons for your answers. Okay, so this is a graph of f. So if I want to know what's happening with f prime is the slope, because it's the derivative of f, so it's going to be the slope. F double prime, it's the slope. It's also, f prime tells us whether our function is increasing or decreasing. So we really could look at either one of those. Okay, and then f double prime, if I'm at the graph of f double prime tells me about the concavity. So we'll be checking out the concavity of that. So if I first of all look at f prime from -5 to -2, it's this section up to here, -5 to -2, I notice that the function is increasing, so the slopes are positive. So I'm just going to put a plus sign. If you want to write the word positive, go for it. And I will say why in a minute, I think, because it did say to give reasons for your answers. Is there anywhere else in? Okay, so from -2 to 0, I notice that this is on this area. F prime, the slopes are negative. The graph is decreasing, so f prime will be negative. And then it says from 0 to 3, so 0 to 3 is this segment right here. I notice the function is increasing and the slopes are positive. And then the next part from 3 to 5, I notice that the graph is decreasing and the slopes are negative. So f prime would be negative. So if I want to give reasons for those, f prime is positive where the slopes of f are positive, or I could also say where f is increasing, and then I'm going to say f prime is negative where the slopes of the f are negative. Okay, then looking at f double prime again, we're checking out the concavity. So if I look at the concavity, I'm concave between -5 and -2, which is again in this same area. I notice that this part right here is concave down like a frown, so f double prime needs to be negative. And then from -2 to 0, I'm still concave down like a frown on that as well, so the f double prime will be negative. And then from 0 to 3, there is no curvature at all, so the concavity will be 0. And then same thing from 3 to 5, there is no concavity, so there's no curvature at all, so the concavity would be 0. So it does say again to give reasons for my answers. So I'm going to come up here. F double prime is negative where f is concave down, and then I will say f double prime is 0 where there is no concavity, or there is a straight line. Because there's no curving going on there. Okay, so that's that part, part A. Get ready for just a total switch. All right, B, there is no value of x in the open interval -1, 3, at which f prime of x is equal to f of 3 minus f of -1 over 3 minus -1. Explain why this does not violate the mean value theorem. So this is saying that there is no place where the instantaneous rate of change equals the average rate of change. So it's basically saying that mean value theorem does not hold. Why does it not hold? Well, we know in order for the mean value theorem to hold, the function must be continuous, which it's definitely a continuous looking function, but it also must be differentiable. And we're talking about from -1 to 3. So -1 to 3. Please notice that between -1 and 3 there is a sharp turn, and we know that sharp turns the function is not differentiable. So it does not violate the mean value theorem because f is not differentiable spelled it way wrong, at x equals 0 because of a sharp turn. So we don't have to worry about it following the theorem. All right, part C. Find all values of x in the open interval, -5 to 5, at which the graph of g has a point of inflection. Explain your reasoning. All right, notice this is a graph of f. All of a sudden we're talking about g. So we need to go down to something I circled earlier. G prime of x is equal to f of x. So this is not only the graph of f, it is the graph of g prime. Okay, so this is a g prime graph now since we're talking about f. We're no longer talking about f. So g prime, here we go. Okay, points of inflection. We know points of inflection, we need to check g double prime. So I'm going to make myself a g double prime chart. And I'm also just going to come over here. A lot of times the people reading your paper want to know how are you connecting g and f. So g double prime is going to equal the derivative of this graph, which is going to actually be f prime. So I'm just going to make that connection. So g double prime, if this is g prime, to make a g double prime chart, we are going to look at the slopes. So we are looking at the slopes because we're looking at the derivative. So slopes, the slopes are positive until I get to -2. The slopes are negative till I get to 0. The slopes are positive till I get to 3. And then the slopes become negative once again. So if I'm asking where is there a point of inflection, there are points of inflection at x equals -2, 0, and 3. And that is because g double prime changes sign. Okay, and then that's it. Alrighty, D. At what value of x does g attain its absolute maximum on the closed interval -5 to 5? Give a reason for your answer. All right, so g, again, this is the graph of g prime, because we established that in part C. If I want an absolute maximum, I first of all need to find critical values. So I need to find where does g prime equal 0. Well, notice that g prime only equals 0 at its endpoints. There's no place in between. So when I go to make a g prime chart, there's really nothing to put. Put -5 and 5 on the endpoints, but there's nothing to put on either side. So then I have to look at g prime. I notice that g prime is always above the x-axis. So this g prime is always positive. That means that the function is increasing on this entire interval. So if I'm looking for an absolute, there's nothing, usually we like find g of -5, g of 5, g of the critical number. We can't do that because, number one, we know nothing about g at this point in time, and we know the function is increasing. So if I'm looking for an absolute maximum, we know g between -5 and 5, it's going up. So if we just think about it, the function must reach its absolute maximum at the end. Okay, so it says at what value of x does g attain its absolute maximum? It's going to be at x equals 5, and it says give a reason, and that is going to be because, I'm not going to say because, I'm going to say since g prime is positive on the interval, g is increasing, so we'll have its maximum at the right endpoint. And that is all I will say. And number 3 is done.